Hi, my name's Simba and this is Simba's Oddities. It's time for a new project. I, like you, probably watch far too much YouTube. After watching all these videos, I've discovered something. The optimal shape for a hammer is not the classical ball peen, but it seems to be a crescent wrench, an adjustable spanner. Now, I can't lie, I have used an adjustable spanner as a hammer before, but there's a few things I find really irritating about it. One is it rattles. Hammers shouldn't rattle. Two, you really need a flat face on the bottom of a hammer to strike with. Curiosity got the better of me, so I decided to have a play and design my own hammer. My design goals are to make this into a setting hammer for the milling machine or a chasing hammer for engraving. The first problem I'm going to fix is the rattle. So I'm going to make it a fixed jaw, which sort of negates it being an adjustable spanner, but it's going to look something like an adjustable. After a bit of playing around in CAD, I came up with this design. Once I was happy with it, I 3D printed a prototype, and I made a quick handle out of some scrap wood lying about. I know it doesn't look good, but I really like this hammer. The balance is almost perfect, and the handle fits my hand brilliantly. I liked it so much that I used it until I broke it. So I epoxied it back together, and that's why it looks a bit shiny. So what material should I make this beauty out of? How about titanium? I just finished a previous project using titanium and really quite like working with it. Online I have seen hammers made out of titanium, and I've always wondered what difference does it make. Is it just hype, or is it actually worth the money they're charging? So after another eBay find, a couple of days later I ended up with a block of titanium. So what's the plan? So this job is all about the order of operations. After a bit of thinking, I came up with a strategy. Basically, most of the work will be done on the milling machine with a rotary table. So let's head there now. As the part I'm making is purely aesthetic, there are no real dimensions or tolerances I have to hit. Saying that, I made a note of the radii from CAD of each cut that I will need to make, and offset the cutter from the centre of the rotary table, minus the cutter radius. Having already sketched the outline of the part on the stock by printing off a template made from the CAD model, but only 2mm thick, it was just a case of lining it up with the Mark 1 eyeball, clamping it down, and away we go. Stepping down a few mil at a time till I hit my depth of about 26mm. Then it was just a case of repositioning the part for the next feature. As you can see, I got quite close to the clamps in a few positions. Why is it rotary tables never allow you to get your clamps in where you exactly want them? After I did the concave radii, I moved on to the convex ones. Next, I milled in the slot for the opening in the jaws. The last stop I did on the rotary table was the slot for the adjuster screw. I then mounted my little vise onto the rotary table using this setup. I milled down the face to the correct depth on the first side, leaving Flipping it over, I did the same on the other side. Mounting the part vertically, I spot drilled and then drilled the retaining pin for the adjuster. Turning the part upside down, you can see why I mounted my mini vise on the rotary table, so this makes it possible to do the round hammerhead face. I could only do a full circle to part depth. Then it was just the case of doing a partial circle on both sides to full depth. This was slightly challenging as I had to get as close to the side of the hammer as I can without gouging a mark into it, or without leaving too much of a step to try and polish out later on. After all of this is what we've got left. The next bit requires a bit of setup, as I'm trying to put on the angle on the side of the jaws. This is a compound angle, so it took a little bit of thinking to get it right. Then it was just a case of setting it up and taking the cutter down until it just touches the corner of the hammer face. The cutter I'm using has a 1mm radius on the bottom, so this helps any slight blemishes doesn't leave a sharp edge. It also helps with titanium as it reduces the chance of chipping a tooth. This operation was repeated on the other side, but because the part is handed, I had to redo the setup. That concludes all of the milling on the main hammer head. I decided to file the corners out in both the slot for the adjuster and the opening for the jaws, just because I thought it would be easier than trying to set it up back up in the mill all square. From the pieces I've offcut, I will make the retaining pin and the adjuster wheel, hence why the square shape. After centering it up in the forejaw on the lathe, I turn the shaft to the correct dimension. Which I then run a die down. After flipping it round, I shape a slight dome on the end and give it a quick polish. As the offcut was so small, I had no material to clamp on, so I had to think of another way of holding it. I opted for a tapered mandrel through the centre of the hole. My lathe is a bit unusual in the fact it doesn't have a reverse gear. You have to use the thread gauge on the lead screw. As this was my first attempt, it probably wasn't wise to try and do a multi-start on the only piece of titanium that I have. This worked fine for turning the radius, but it didn't cope with the amount of torque supplied by the single point screw cutting. Or maybe I got a little aggressive with my depths of cut. Either way, I had to finish the grooves manually with a file. And now a quick word from our sponsors. Jehovah's Witnesses, 12 inches, tractor pulling, anal leakage. That was interesting. Let's get back to the hammer. Onto the handle. Hickory is the classical choice for a hammer handle, as it's got both the strength and the durability to withstand all the impacts. But it is a bit boring. I happened to come across a lump of walnut, so I thought we'll give that a go. Hopefully it'll add a bit more character. I roughed out the material on the bandsaw, working in one plane, then turning it over and working in another, just to get the rough shape in. I have no woodworking tools, so I'll just shape the handle to the best of my ability on the bout sander. It was all done by eye, so it's probably a bit crooked, but I like the look of it. I added a hole and a recess at the back of the handle for some detail. I may engrave a brass plate now that I have a pantograph and fit it in the recess, just to make it look a bit more interesting. I didn't video making the handle, as it was just me eyeballing it on the bout sander, and you wouldn't have seen much anyway apart from my fat ass getting in the way. I then made the tenon with a saw and a file, slowly working my way till it was a real tight fit. I was aiming for a Dali-esque sort of mounted look for no other reason than I thought it might look interesting. So that's all the parts done. Just need to clean them all up and give them a quick polish before fitting them all together. To fit the handle to the hammerhead, I made a wedge and then fed the wedge into the opening for the adjuster. So that's it all done. I know it's not the best hammer in the world, but it's a bit of fun and I really like making it. I hope you liked it too. If you did, please consider giving it a like as well. Overall, I'm happy with the result. There's a few things I'll do differently. I'm not quite happy with the adjuster nut. The grooves aren't all equally spaced and it really messes with my OCD. As the head of the hammer is made of titanium, I may try and oxidise it to a nice purple colour. As I said, I might make a brass inlay for the handle, but apart from that, I'm extremely happy with it. If you want to see me make this with the help of a 3D printer, then consider subscribing. Thank you for watching.